The title of the talk in the brochures is confusing, let's say it that way. Really because I didn't know how to pitch it. So over the last year, I've been working on something largely outside of HOK with HOK's blessing, so this is very much my view of the world. Obviously, I do work at HOK, so that's where a lot of the information comes from. But this is the point. I'm gonna sort of be the James May of the group today. I'm gonna ramble on in facts and figures, but again, I swear I did not know I was gonna talk about this. The only reason I saw my profile in a window this morning and I realized I sort of had a similar haircut at this point. So let's get into it. So about this time last year, a little bit sooner, I sort of took the work that I've been doing for a long time, which is evaluating the industry, looking for better tools for our employees and our staff, and just thinking about broadly in the industry, and I'm sort of lucky to have a role like that. And I think there's a general feel that maybe technology isn't serving us the best way, and I'll be very specific what I mean. But the question is, are we really being served by the tools we have? And so, the things like the open letter group, thinking about cost, but I think there's another sort of avenues, thinking about productivity and words that people don't necessarily like to talk about that are important, that I think are key to the discussion that I want to sort of really dive into. So I'm an architect by training. I was speaking to someone last night. You'd never ask me to sign anything because I wouldn't, but that's my, so up until 2006, that's what I did for a living. I'm a technologist. I'm not a developer, which is odd for someone in my role. I don't touch, well, frankly, I can't. I'm quasi-dyslexic in programming languages, so I don't do those things. And I'm lucky in the fact that because of that, I've sort of had this need to understand tools without wanting to always customize them and make them my own, and you get to see the gaps if you don't have that capability, I think. So what did I do? How are we doing in the basics? So this is basically let's just put it in context. In the BIM realm of discussion, how are we doing there? I also looked at if there was something wrong, could we do something about it? I think the key thing is this is what we're going to talk about today, how the basics work or don't work. And then finally, sort of why focus on that, which really is, in a full service firm, it's 70% of the work. I'm going to talk about things that aren't the most interesting stuff, but they're the way we convey our work, and it's often the place that we use the most time. So really not about a particular BIM, but the tools we use to produce them. And that's nuanced, but it's to say I'm not talking about a particular vendor, just like think of the 4 or 5 BIM tools you can think of that really sort of generally all work in the same way. So it's hard to sort of get into this without a framework, and I didn't really understand how to get into it until I would say January of last year, which was really we don't go through and count the steps and how we work, and I think it's an important aspect of evaluating it, and so that's what I did. I came late to using an old graph, which is the McClamey curve, which is basically a curve about a bunch of things, influence of cost and time and those sort of things, but it's about effort. And it's interesting to think about what effort is, and so I'm using effort as a stand-in for doing the work. And what is in the to here section, I think is up to every firm, every company to think about what they want to do. I think it's important that we make that possible. So what did I do? Well, I make a bunch of slides, a bunch of presentations. I've talked to different groups of people. A lot of it doing a mix of both talking about the technology, but also talking about how we could sort of solve some of these changes. And I'll just preface this, and I'm not going to talk about a whole lot about that, but definitely there's a mood in the industry to start to look at how these can be solved in partnership with software vendors, startups, and those sort of things. And I think it's an interesting story to keep moving. So in that context, if we were to do nothing, we'd sort of get the future we'll get, I guess is the view I sort of had as of last year. But I think it's important to think about, to get the future we'll need, we really need to spend a lot less time on the basics, which is sort of, it's the stuff we end up doing as architects that takes the most time, but might not be the most valuable use of that time. And that these words are also hard: value, efficiency. I think it's important to tread lightly, but the idea that we should focus our work on designing better buildings, and the work of documenting those decisions is something that we should make quicker, faster, and more easy to do. So what's not working? Well, so if we project this curve ahead, so the first thing I mentioned is these are effort curves. And this is, for those of you who don't know, sometimes called McClamey curve. There's older curves that come from the software world that sort of mimic these things. But the idea here was if you move the effort forward in time, you can make better decisions. Whether that's possible or not is a hard question to answer. But then you overlay this with, well, these are buildings we're building, so if you're designing those and they go into construction, the later you work and make changes, the less you'll have ability to influence cost. So there's two of them. The cost of impacting change goes down or up, and the ability to make change goes down. I don't think the important part is here for this talk, but is really, what is this effort curve? So it is an interesting thing where you look around, like we have a lot of discussions in our industry about productivity, and if you look online, you can find hundreds of curves that show how, besides farming, which, by the way, I grew up on a farm, and farming is much better at digitization as our industry is, but you see all these things where we're certainly not as productive as manufacturing, but at the end of the day, I don't think we have a good handle on what effort means or what productivity means, especially in the design space. So the tact I took is, well, let's separate decision and implementation. How fast can someone make a decision, and then how long does it take to implement those decisions? And it's a relatively good framework to work through. I'm certainly not stuck with it, but the idea that as you look at evaluating tools, how long does something take to decide versus how long does it take to communicate? So I think what's happened, actually, we've moved the curve back. You'll see great presentations of really powerful tools that work early in design, but we've actually sort of extended the work because of the complexity of building projects today, whether that's sort of carbon or energy or just construction sequencing, that this sort of envelope has gotten a lot bigger. So what did I focus on? I focused on drawings, knowledge reuse, models, and data, and I'll sort of try to step through these as quickly as possible. It's the first time I've given this presentation, so we'll see how far I fly short or long, but I talk too fast when I present, so we'll go from there. So let's start with drawings. I thought it was important that we sort of actually look at how drawings are actually done in these BIM systems. And I'm doing gross generalizations. Some platforms are better than others at these things. But the key thing is, okay, I take a model, I slice it up, I have some sort of representation. I take that representation and I apply some rules. This is the first place you get real knowledge applied to these things. So I know that I want to communicate a layout, or I want to communicate a furniture plan. Any of these things, they're basic representations of that model. I think the key thing here is you're immediately seeing you've taken one bit of information and you've now made it represented in 5. This is a pattern you start to see in our drawing process, which is we have a lot more representations of models in drawings than we do in models themselves, and it really becomes problematic. So if I take something like this and you actually look at the work, this is why it's a problem. This is most of the time people are spending on larger projects. The models can update themselves. I did this all in PowerPoint. It's my best PowerPoint work yet. Even the ceiling grid. But the key is, if you've taken a model and put it in 5 different places, really what you have to do is make sure it's legible in all kinds of different ways in 5 different places, which is clumsy. But if you take a little look at a slightly larger project, it gets much worse. And this is sort of a problem I think we'll see, that it doesn't scale well. So if you take this idea, and often what you do on a big project is you break these down into 1 to 50s, 1 to 100s in your sort of the local parlance. So you end up with a lot of drawings representing a lot of the information. And then you possibly do a smaller grid. This is not the grid for this project. I'm just giving you a representation. But if you start to look at this, the ratios get crazy. 95 to 1. So if you make a change that actually is represented in all these places, you have to care about 95 different locations, and this is an underestimate, because this is just talking about 2D plan information. If you're talking about sections, details, you could have some model information have 200 representations that you have to worry about as a designer to implement, which is mind-blowing to think about, but you can imagine why it takes so much time. On this particular project, there's over 1 million pieces of annotation. So this is just, it's depressing to think about the life of an architect that has to care about finding all these little changes of annotation that happen in our drawing process. But it's sort of what it is. And this is, I'll be clear, I point this out later, this is just architecture. Airports are much more than that, and they, we're probably talking in the several million if you include everything. So let's look at this. Changes 95 times. It doesn't come through, but this is my attempt at making a GIF. You have to have a GIF in a PowerPoint. You'll see it again, but this is 95 different updates. You probably can't see it, but there's a whole host of different colored ones, which would be the ones that you just missed because you didn't even know it changed. Because the tools really, speaking broadly, I don't think any of the platforms help you understand where, oh, you made a model change and you've affected all of these locations. So let's look at a little smaller scale. So this is LG headquarters just across the river from New York City. So if you look at the counts, on the left is going to, yeah, that's your left. That's doors, or not doors, counts of objects, and then how many pieces of annotation. This is actually much more sort of in line, something like, I think it's like 60% more annotation. My graph reading isn't so big, but you can imagine why, as I play through my animations here, we start eating and eating your project time into this process. This is a fine animation. I didn't get to get the mouth moving, but at the end of the day, this is our estimate of how many billable hours we spent on building a model and then tracking down all the changes. So our practice, like within HOK, given the number of projects, that's a $45 million problem. And you wonder why the industry sort of struggles with the pace of tool development. And that's in the context of tools like this. Like, the left, obviously, is what we're doing. The newest Pixel phones can find people. You don't even have to point them out, grab them, take them out of the image. We have none of this advancement sort of in our world. Or at the same time, we've had zoomable, scalable maps for a long time where, the information could display based on scale. We have none of this information, sort of innovation in the drawing world as well. So not only are we producing a ton of drawings, we don't have a way to re-represent them in a way that's much more nimble than our old style of delivering those. So we have massive data duplication, non-existent change management, the packaging. This is really the how drawings are delivered. We need drawings. I don't think they go away, but at this point, we should be thinking about how drawings are free, and they're far from it. When I say free, you build the model and you should get the representation for free. So let's talk about knowledge reuse. Now, I sliced up the initial curve just to think about the fact that if you wanted to deliver on this promise, you really have to realize that you can't reinvent everything from a project. And if you want to do things like design to manufacture or any sort of advanced building delivery processes, you have to think about what's new and what is just stuff I already understood or could apply in this new context. And this is sort of an interesting thing to think about in our world, because that, sort of the majority of the work is reapplying knowledge you've already acquired or used in a new context. So the reason this is important is if you look at basically a project sort of development cycle, early on in a project, I'm using doors because it's so dumb and simple. Some people that deal with openings for a living wouldn't say that, but it's an easily representable piece of information. Early on in projects, that data already exists. The door there is there. Everybody knows you put it between two rooms. You maybe add a couple, but really what you're doing as you sort of move forward in the project is you're adding detail to these representations. So, the frame, the hardware, or, sort of possibly the thresholds, but this is sort of the work that gets done as you move forward in a project. You're not deciding again that I need doors over and over again. You're just adding to the resolution of that information. It's interesting to think about is this is what our BIM tools do. This is it. This is the knowledge they bring. Every one of them, you put a door in, it knows to cut a hole. Everything else you have to bring to the table, and this is a problem because if we look back at the graph, this isn't the hard part of the work. Knowing the door should go there is the easy part. But if you look at sort of any experienced architect, interior designer, they've seen a condition like this 100 times, firms, thousands. So yet we can't make sure that the door that gets put in that kind of wall are the right assembly. These sort of tools don't exist in our market. Or at the project level, understand that at this project, this is the relationship between these kind of spaces and I should have this kind of hardware. All of this is brought by the designer and input into the tools. The tools don't have the ability to use this information in a way that, for lack of a better way of thinking about it, it's just not wrong first, right? A lot of our tools, the way you work is you make it wrong and then you fix it. Well, why can't we be in a position to not have to fix it or have a smarter default? And then obviously if you had like finish information, you've described this door as a series of the system it belongs in. You don't have to actually think about the door. But this sort of concept is devoid from our sort of tools. And then finally, going back to the drawing discussion, well, if I've already seen this condition in a frame that goes with a certain kind of door, I certainly should not have to know I have to grab the details to detail this in 2D. But in all the systems generally we have, that's certainly the case. So if you looked at those decisions, I have one new one, and all these others that you probably could inform from previous work. Certainly they would be tweaked. I'm not suggesting that every building is the same. I'm just suggesting that if you started with 7 of those, let's use 30 for the hardware. That's probably like 35 decisions. Let's say 7 are right out of the gate. You're already in a much better place than having to revisit every one of these. So if you continue on to look at this, so the previous chart on the left was count versus annotation. So that's how many, like this bottle, how many times did I label that, count versus annotation. Now the second one is types versus count, which is to say how many unique configurations of anything did I have in the project versus how many instances. It's obviously not 50,000 doors. These are, again, just representational. But that's an interesting relationship. Does anybody have any idea if that's a good relationship? I actually have no idea. I'm being totally honest because there's actually no way to know this information. So I can't tell you if having 1,407 unique configurations on a whole building is good. No clue. But I think that's part of the problem is we totally skip over this topic we'll talk about in a second, which is how things come together and are reconfigured. It's almost like we blow up the project data at the end of the project. That's good work, right? It's almost like we blow up the project data at the end of the project because we can't possibly evaluate that. We can count the number of things, but we don't know if those number of types match the number of types we actually needed and how they were configured. So we have no good way of applying this knowledge. We have libraries, but having that door, in a library required somebody to reuse knowledge. It wasn't helpful. And you end up redoing the same work. And the same thing, just to bring it back to the drawing discussion, certainly applies again. It's not hard to imagine how you could decide how all your drawings look with a set of rules, how they should be labeled, and that as you work, it just shows up that way versus what we have today, which is create those on the fly each time. You can start with some templates depending on the tool. And obviously, sort of where that tag exists in the ceiling plan versus the furniture plan. So let's move to dumb models. And I use that term because it's everybody has got to be ready to say, oh, we should just deliver models then, right? Well, let's get into that, because that's clearly the place we should think about. You know, if we're doing all that work, that's clearly where we should be spending our time. There's no 1 to 95 and if we're delivering a model. But outside of these things, which we don't have to actually deliver models well, I think, there's a whole set of topics that we have to get into. So the 3 things I'll touch on are dimensions, tolerance, and algorithmic feedback. I won't go into too much detail, but I think if we want tools to build models for us, we have to be able to have them communicate back to us, and it's a very similar problem to this one. So in that LG North American headquarters project, I went through and counted, obviously not manually, 21,000 odd dimensions. Some of these are in details, reference back to structure and stuff like that. You'll get a lot of dimensions. But again, is that a big number? And I mean, this is the only project I ever really have done this on. I have no idea if it's big or small. Are things over-constrained or not? These are concepts we don't really have a good understanding. Dear software, tell me all the things I haven't dimensioned is not a feature that exists in any of the tools we have. So it's impossible to know if that's too big, too small, or just right. The other thing that we don't have is a way to deal with tolerance. So let's say we're actually sort of want to base our building off the rooms inside off the interior wall. So we showed an elevation, we throw a column in there, and I think people think we build buildings like Swiss watches, which car company end watches is an interesting follow through, but it's interesting when you start to look at tolerance. This is not a place I spend a lot of time, but when you start to get into, okay, how do we deliver models, you have to think about these things. So this is US tolerance for construction of concrete, cast in place. So up to 84 feet or 26 meters, it's very tight, but if you go up to 500 feet, a column, and they shift together, so don't imagine each column doing this, they sort of do this, but basically can be within 6 inches at 500 feet. And all these tolerances are, steel has different tolerances, but we don't have conventions to handle those things, and so that's why we have drawing conventions, right? So there's that column, it could, like I said, move on its way up, and we don't have a way to communicate those things. I apologize for going away from the mic. So if we wanted to dimension that space, but it was important to keep that space clear, how would you do that on a model? All the model would have is where those 2 walls on with an assumed arbitrary spacing, but you don't really have the tools outside of drawings to communicate that. So this is where we start to need to think about, we need to encode, I guess this is the way to think about it, flexibility into the models themselves so they can understand where I could be made up. So maybe that end space is flexible so you could get the 2 feet, 2 meter or 2.8 clear that you actually need. But indicating that in a model is something we don't have the tools for today. Or that corridor needs to be the same width, or that wall needs to be placed that way. And then finally, I mentioned the algorithmic thing, which I don't have time to touch on today, but if an algorithm placed that door, which a lot of companies want to, sort of do that first step, make those models for you, that first decision, well then, how does someone actually know why that door arrived there without a way to communicate that in the model itself? I think there's a blindness to the fact that if you wrote the algorithm, it's easy to know why the door arrived there, but if you didn't write it, it's arbitrary. And that communication is something we don't have as well. And I think it's interesting, we'll see some speakers from Boston Dynamics later. If you had that logic in a model, you could actually evaluate tolerances in the field directly because you could understand if the scan I'm getting back matches in that wall placement is within tolerance, but we don't, again, have those sort of things encoded. The big one here, though, is you'll see in the animation I'll provide you at the end is the big gap. And I showed this earlier. So we don't put 50,000 things in a building just freestanding, right? They interface with each other. And we have a 2D version of this, which is called details. We have none of this in 3D. You know, you can model these things, but we don't even have a concept of interfacing between systems that is well defined in more than the items themselves. So just to do some math, like, is this a good starting point? Do I have 80 wall types and 70 door types? Architects might. Contractors would never build this many. They would chop this off to like some small digit of things that are very close to each other. But how many combinations is that? And let's be conservative and divide by 2 and divide by 4. And do I really have 700 combinations of just door-wall intersections that I have to think about? Frankly, I have no idea. If anybody does, please see me after, because I don't think outside of maybe QS roles or something like that, this is thought about, and it certainly isn't supported in software. We can take another approach, which is just to count, take that same room, count up the items, and see if we can apply that in other spaces. So if you take the walls intersecting walls, I missed one on the door already. If you take doors intersecting the floor, walls intersecting the ceiling, walls intersecting the floor above, you're up to 13, maybe 15 interfaces out of 6 elements. Again, are these the right numbers to think about? There's an interesting conversation about producing too many drawings. Well, this is the sort of stuff you sort of have to consider. Why are if we don't know the number of interfaces, we do have to sort of document the numbers. So there's that 6 of the 20 ratio, and now that I look at this graphic, I don't know why it's here, but clearly this is what an interface is. So, but if we expand this out and to look at the larger set, there's 6 to 20, apply that to our larger building, do we have 160,000 unique conditions of 2 systems coming together? I doubt it. Could be more, could be less. I think the point here is we just have no idea. And from a knowledge and industry perspective, waiting for the transitions, it's sort of like a black hole, right? Because we just have no idea. That's the final one you'll get, so if you appreciate them, now it's time to clap. No, just kidding. It's a boring topic. I have to put fancy slides in here, so this is just thinking about architecture, not thinking about other disciplines. Discipline to discipline interfaces are a lot harder even. And then finally, there's huge gaps in those general concepts of model deliverables. So wrapping up, lazy data. During this whole time, I've shown you one graph. Clearly, there's not one. There's potentially, on a larger project, you could have hundreds of different disciplines working at different phases, and communicating all those things between groups is something that, again, is not really addressed. We can work together in the same world, but actually communicating that data is not something we're good at. I give you the text message, and I'll give you the text message invented by AEC after this. Everybody understands how this works. Someone sends a message, someone receives that message, and they got the content. Direct, like you didn't have to download the text message. Well, wait for it. So let's walk through how an AEC text message would work. I sent you something interesting, you have to look at it. You get an email about something interesting. You go to the website that says download something interesting, and of course it's one version of the truth. Which one, I don't know. You get it downloaded, you reply, great. Oh, by the way, here's the update, right? This is how our industry works. Our data is actually, like we do a lot of work to put it somewhere for other people to go get versus the opposite, which is, no, bring it to me. I'm the one that need it. Don't wait for me to go deliver it or have to go download it, what have you. And this is very much a design concept. In the design process, you don't want to have to be the work you have to execute is going to get things. You want everything you need there. And that's something that's sorely missing in our industry. So really, I've worked through this. I think I like wells, but we can go from there. We sort of have this idea of data wells, but we keep doing things like this. Come on. There we go. So instead of doing what you typically do in a well is you take the water out. Let's say it's a water well. typically you take it out and keep it out, but we seem to do these things where we keep moving the data between other applications, right? And if you're counting along, it's double. So if you have 3 wells, you have 6 pipes. And the reason I bring this up is because really this is a human task. Oh, and by the way, sometimes you have wells, you'll get some data out, but you'll never get it all out because it's in a proprietary format or something like that. It's important because people are the pipes in our industry. Like I said, like that whole text message example, that means you have to go do the work. There's no, the idea that APIs will get there eventually is an important one. But at the same time, it sort of spreads everything out and then makes people go bring it back together versus the opposite, which is, I think, what we want. So the logical thing that we've done is, well, we made reservoirs, which you could call CDEs, and then we went beyond that. Well, we just have a CDE per platform. But basically what you're sort of seeing there is by choice or by technology, those begin to be buckets that don't really solve a problem, and they begin to become other destinations. Sometimes they add features that are sort of helping you analyze that data, but it's certainly not the case always. Sorry, I'm going too fast here. So this is definitely an interop versus interchange. USD came up in the first session. This is really the thing that I think is the most important for our industry to look at, is USD is trying to be an interop format, as in the data always exists in USD, and then you can use it in other tools versus having to move from tool to tool. We don't have anything like this in our industry. We have interop approaches, but if we look at, we have confusing myself, we have interop approaches. Interchange is this idea of being able to interchangeably switch out the tools on the same data. So to make that a reality, what you would actually start to do is think about, well, doing the heavy lifting with software and computation to move that information out. You lessen the number of connections you need. It's going to take work, so it's not free. But the initial benefit of that is that information just flows to the people that need to consume it. If you're looking for a reference, this is basically how, sort of Git-based software development works. You put it all in the bucket. When you need anything, you get all the copy you need. You do your work. You have everything. You might not know that when you compile, you're using 50 different pieces of code other people touched. You don't need to know. It just flows to you. We would probably need to do more than work than this, because in our industry we have a lot more different kinds of data. So I live in New York. Everybody wonders why we have water towers in New York. It's basically data caching. Put the water on top, so if you have a fire, the water's at the ready. And the same analogy applies, and this is why I like wells and water. You can do things on the way that makes it easier for users. You can filter it so they only need to look at the data they need. You can clean it, so they don't have to look at everything that's a mess. I really don't know what the fire, besides heating up water, it was the logical thing to put there, but you can imagine you heating water and heating data. But the point is, you can only get the trickle of information you need versus the deluge that we sort of would have, even in this scenario. If you just try to use the pipe, you're flooded with information. So it's interesting to understand why this is important. I'm sure I've been describing and thinking about models, but this is an analysis of the different places material information shows up in our workflows. And I think you'll count 13 different places, and we have no way currently to coordinate any of that. And I think the key thing of thinking through this is that we have to think about these as resources that are computable and human readable versus what we generally do today is just human readable. And so if you ever wanted to, say, have a visualization change what shows up in a specification, we need those two data sets to talk to each other and talk to each other automatically. So I'm at the end here. I think the whole thing to think about is I talked from the beginning that this is the boring stuff. This is the basics that has to get better, because clearly we have other much more intractable problems right now, like energy, carbon, and then building these things. Clearly there's a pipe into pre-construction that we don't have today because we can't release information. That's a whole nother topic. But I think the key takeaways from this section is just the data stuck in these silos, and it's odd to think about, but we only really use compute to show people information, not other computers, and we can have nuanced conversations of that, but it's a theme you see. So I started this with the fall last year. I think it was pretty, I went to it both from a professional sense and from a personal sense. Am I really having an impact? And I think mid last year I was sort of thinking that, well, this is too an intractable problem. But I mentioned there's ongoing work to take some of these ideas, and I'm spouting all of them. You can't work on all of them at the same time. But okay, could we as an industry come together to address some of them? And I think that's actually starting to happen. But I think there's a discourse need to be happening about the problems as they exist in the different domains and how to bridge them together. So generally, I guess what I'm saying is if the low point of this discussion was last year, I think I'm at a pretty high point now that there's actually a path forward in all of this. Thanks.